So I'm Leo Francis A. You are K24CO 2005. This is Machine Learning Laboratory experiment number 8. So here I import the packages from Python like NumPy, Pandas, and matplotlib, and the minisum and the three things from sklearn, which are pre-processing, decomposition, and metrics. First, I'll load the data set and display it to preview to understand its structure and features. And the second is pre-processing, data pre-processing. Here, I clean the data set by removing the missing values and converting the categorical variables into now a numerical format using encoding. So this ensures that the data is suitable for clustering. So the next one is removing the target variable. Since clustering is unsupervised, I remove any target or label column if present. So this allows the model to discover patterns on its own. So the next one is for feature scaling, where I normalize the data using a standard scaling so that the all features contribute equally and the distance calculations are not biased. And the next is data visualization using PCA. So I reduce the data set into two dimensions using PCA and plot it. This helps visualize the structure of the data set before clustering. And the next is the self-organization, the self-organizing map. So here I apply the SOM, self-organizing map, which is an unsupervised neural network. It maps the highest dimensional data into a 2D grid. Similar data points are mapped closer together. Each neuron represents a cluster. So the next thing is the running the SOM for multiple clusters. I run the SOM algorithm for different number of clusters, 2 to 9. For each case, I assign cluster labels and I compute centroids and visualize the clusters and neuron positions. And the next is evaluation metrics, where I evaluate clustering performance using slide score, where the higher is better, and Davis Bowden index, where the lower is better. These metrics help determining the clustering quality. And the next is the optimal cluster selection and the final result. Here I select the optimal number of cluster based on the best Silhouette score. Then I run the model again with this same value and to display the final clusters and final centroid and visualization. So the SOP self-organizing maps provide a powerful way to visualize and cluster high dimensional data by preserving its own structure in a low dimensional space. So this is experiment number 8. Thank you.